Yes, I'm a professor of climate science at University College London. I've been working with an interesting set of neuroscientists and communication specialists. But I'm also chair of the London Climate Change Partnership, which is a partnership of public, private and community sector bodies in London that essentially are all of the main players in London, and our objective is to work together and achieve a high level of resilience against climate change in London. So I'm here in both those roles. Now, we've heard several times this morning about the importance of carrying citizens with you. We heard how carbon capture runs into trouble. We heard a little bit about fracking and so on. Doesn't matter what sort of political system you have, that's true. So this is why the talk is called Bridging the Gap. We're an unusual audience in here. We don't represent humanity in general. People have to be persuaded and motivated that the measures that we're talking about are worthwhile. Here's a thought from a rather bright individual from history. Einstein said, to tell a complex story, it's as well to make everything as simple as possible, but not simpler. And the not simpler is important. There is a temptation to oversimplify, and then when you do and the true complexity emerges, then your people's belief in what you're saying can be eroded away. So this is quite tricky for the climate science community because here we have this object and it's the most complex object that we know of in the universe because it's got geology, it's got physics, it's got chemistry, but it's also got biology. We no doubt all of us here believe that at some point there may be evidence found for biology elsewhere in the universe, but there's certainly no evidence of a complex technological civilization like our own. So to understand this object is a hugely complex and challenging task. It is unaware that it's so complex. It just works. It functions as an integrated whole. And so as scientists deconstruct it to try and understand how the various pieces work, whether it's deltas or the ocean or the atmosphere or the biology, the Earth goes on with its interconnections. And so the science community not only has to understand the pieces, but it has to understand the interactions between the pieces. And the more pieces there are, the greater those number of interactions. So telling this story in a way which is simple enough but not too simple is a very challenging task. And of course, this object provides ecosystem services essential for life, and most of us go about our daily lives without thinking about that. So there's a sub-story. Why is the science important? Why is the story that the science community is telling relevant to you in your tube journey or on the bus to work in the morning? That story has to be wrapped around this in a way that connects to people. We've heard that there's no planet B, it's finite, there's no spares, there's no escape hatch. If anybody thinks we're all going to go and colonize Mars, then I think they're going to be unhappy when they discover that we're not. And it's sending us warning signals. Now, those warning signals have been detected and interpreted by science. I don't agree with a lot that Bjorn Lomborg says, but I do go with him when he says that his grandmother, who reached the ripe old age of nearly 100, when asked what she had seen in her life, omitted to mention that sea level had gone up 30 centimetres, because she hadn't noticed it. We only know these warning signals because of the science community and its efforts. And one of the signals that is of particular importance is this 400 parts per million. If all of us just take a gentle breath, we are privileged to be the first humans ever to breathe that amount of carbon dioxide in with our air. That level, we know, has not been seen by the planet for at least 800,000 years, probably many millions of years, and it's reached that level in an amazingly short time. That rise of 100 parts per million, which is the same change between an ice age and an interglacial, when the global temperatures change by about 5 degrees, more at the poles. That's happened 100 times, maybe 1,000 times faster than any natural process. And yet, in our daily lives, we are completely oblivious of it. On the other hand, if we were a set of aliens monitoring Earth, and goodness knows maybe they are, and we were looking at the Earth with eyes that could detect heat radiation, as this satellite image does, what we would see is that this heat radiation, which is leaving the top of the atmosphere over this last 100 years, has substantially cooled because the energy that the Earth is collecting is not escaping, it's accumulating in the system. And we scientists know that's important because where that energy goes changes the climate system that we inherited and that we use to build the modern world. We adopted it when we invested all of that energy, all of that money, all of that effort building the modern world. We're not well matched to the climate system we inherited. We're certainly not matched to the climate system which this change will provoke. So, you heard from Miles earlier, the science community not only does its work, but it tries to assemble an evaluation every so often of what its conclusions are. And we had last year the latest reports from the Intergovernmental Panel on Climate Change, arguably the most thoroughly and rigorously reviewed scientific document in history, possibly even the most rigorously reviewed document in history. And the statistics you can read, hundreds of lead authors, thousands of publications reviewed, tens of thousands of comments responded to, approved by governments and so on. So this is a highly authoritative statement. But it's interesting, isn't it, that the climate science community's statement is quite complex and technical. And it's a politician, John Kerry, who I think provided a rather nice short summary. And he said, boil down the IPCC report, and here's what you find. Climate change is real, it's happening now. Human beings are the cause of the transformation, and early action by human beings can save the world from its worst impacts. So there's a nuance there. We have a lot to do by way of mitigation, but we have already committed ourselves to a degree of climate change to which we must adapt. Now, the majority of climate professionals agree with this. Whether it's 97% or whatever, it doesn't really matter. If you go and speak to professional climate scientists, you will find relatively few who don't accept that John Kerry statement. But it's interesting, isn't it, that if you look at the concerns of citizens upon whom political action in the end depends, they have a very different view. This was a Yale study of a few years ago of citizens' concerns in the United States, and climate change was then 14th out of 15 issues, and not much has changed since. It's different from nation to nation, but this is not an uncommon story. So there is a gap. Something is broken. The message is not getting out. Furthermore, we all know, as Miles said this morning, that even if this graph were horizontal, at level 22, we would still have a problem because the energy balance of the planet would still be out of kilter. We would still be accumulating energy. That is, we would be emitting at a standard level zero, but keeping that level of carbon dioxide at 400 parts per million. But in fact, what's been happening over this period is the rate at which we're burning those fossil fuel resources has increased. And I just remember something called the Kyoto Treaty, which I think committed everybody in the world and the nations of the world to have reached a level 5% below our 1990 emissions by the end of 2012. And in fact, we're up 60%. So even if the citizenry aren't getting the message, neither are those involved in generating energy. And what we know is that there are limits to adaptation. Those that say, well, let's sit back and wait and see what happens, ignore the fact that there are huge risks, which I guess everybody in this hall clearly accepts. And if we look at the London Assembly, with whom the London Climate Change Partnership is working, they identify economic consequences of climate change for London under direct national impacts, flooding, overheating, water shortages, and so on. You know the list. The international aspects, we're connected in a highly intertwined world. So when my wife went to collect her spectacles a year or so ago, she was told they weren't ready because of the flooding. And she said, but there isn't any flooding. They said, well, there is in Bangkok. And that's the world that we live in. So nobody is immune from the effects of climate change. There are then indirect impacts. If finance is going into insurance or into protection, it's not going into other things, into making the world a better place, helping the poor get out of their poverty trap. And then there are slow impacts. As the world slowly changes, the way that business and people work will need to adapt as well. So why is it that we are not reacting? Why is it that those carbon emissions are still going up? Why is it that humanity is struggling with this problem? Well, if I were a mischievous demon and wanted to set humanity a problem that would catch it out, it would have these characteristics and more. The evidence would be complex and technical. And I've said we see these changes through the medium of science. There would be a disconnect. Even if I cognitively understood, if I had accepted, I would feel that, well, this is not now, it's not here, it's not me. I need to get food on the table. I have other priorities, those 14 other priorities that we saw in the US poll. There's an idea of slow violence. Our minds are just an organ which has developed through evolution, and they have developed for a purpose, and that's to provide us with meaning in context and protect us from rapid events. So if something starts to fall on me now, my system will energize, and that's what my mind does. It will cause me to try and escape from the violence. But slow violence is something that our minds are not tuned to deal with. There's another problem, and that is that to deal with both the mitigation and the adaptation requires just the small problem of rapid and fundamental transformation of the entire modern world, the energy supply, the economics, the politics, the infrastructures, and the behaviors. And Machiavelli pointed out that to embark on changing the established order of things is one of the trickiest things that one can seek to do. Even if there is acceptance of the need to move, we've seen that there are inertias. It takes time to invest in new systems, whether they're natural or built. There are powerful vested interests, and I don't want to overplay this, but there are vested interests out there who are playing a role in creating confusion and paralysis. And of course, we have inadequate instruments and institutions. This is something that that humanity has not had to confront before, a global problem which needs to be dealt with in a coordinated way at a global scale. Now, where does the science community sit in this? We published a report just recently that builds on work by Roger Pielke in the United States, where we identified 5 roles for the science community. Firstly, do the science. That's obvious. It's what most scientists get out of bed in the morning to do. They get out of bed to go and analyze their ice score or look at their data. They don't get out of bed to go and mud wrestle with politicians on Newsnight or be interviewed by Roger. Act as science arbiter. The facts don't explain themselves, and there are many, many facts and many, many interpretations. So it's the job of the science community to answer positive questions, but not normative questions about the facts. And Mayor Culper, I, like many, responded to a request a few years ago to provide evidence to the Prime Minister on what constituted dangerous climate change, and we should never have accepted that commission, because that shifted responsibility for normative questions into the science community, who are not equipped to deal with value judgments. If you ask us what will happen if we pump another 500 gigatons of carbon into the atmosphere, we can attempt to answer that question. If you ask us what is dangerous, we can't answer that question and shouldn't do so. We need to be better communicators. Most scientists did not get into science to be communicators, and I'll come on to some of the issues that they have to deal with. And we need to sit with the rest of the citizenry and experts making decisions about policy alternatives and illuminating those issues with science, but not arbitrating them with science. And then finally, there's a 5th role that most natural scientists are very unwilling to take, and that is to step forward and advocate particular policies or solutions, carbon taxes or whatever. And at that point, most climate scientists, most natural scientists say, no, that's not my role. But there is a powerful argument that says, well, wait a minute, you have insights and knowledge that other citizens don't have. You are a citizen, you have a right to speak up. And indeed, those insights were paid for by the taxpayer, so you have an obligation to come forward and speak your mind, making clear that you're doing it as a citizen, but not as a scientist. Now, what are the problems the science community confronts? Most of us trained as natural scientists were trained to work in areas that are emotionally and ideologically neutral. So climate change, climate science is not the Higgs boson. If I give you a talk on the Higgs boson, which I'd have to do a little preparation for, I might interest you, I might tantalize you, I might inspire you, but as you leave the hall, you're not changed. You carry on with life. But as soon as you start to tell the story of climate science, and the better you do it, ironically, the more likely this is to happen, you generate within people feelings of anxiety, fear, loss, grief, guilt, and helplessness. Are you telling me I'm a bad person? Are you telling me I should buy a hybrid? Are you telling me I shouldn't fly on holiday? All of these questions are generated, and if the science community, as it tends to do, ignores the fact that it's generating those emotional responses and ignores those questions, then there will be a backlash, and arguably that is exactly what we have seen. More so, the story of climate change challenges strongly held values and beliefs and powerful issues of identity. So those that have a more collective, if you like, empathetic view of the world, who are interested in nature, see nature as our life support system, are interested in reducing harm, collective action, see climate change as a threat and are motivated to deal with it. Those that have a tendency to see the world through the eyes of an individualist who defend personal freedom, who rail against state interference and regulation, have a tendency to see this as a hoax. And these starting points are amplified by the affinity groups. All of us tend to mix with people who think like us and have discourse with those, and so there's a feedback which reinforces and polarizes these views. So it's not surprising that if you look at, in the United States, the response to the question, do you think that global warming is happening, you get a very strong polarization and difference between those who are Democrats, where about 80% say yes, and those who are Republicans, where less than 50% say yes. So how do we deal with this? How do we bring people together? How do we change minds? Now, certainly in the Western world, the classic approach to the great issues of the day is supposed to be by dealing with them through debate. Prime Minister's question time, for example, in the United Kingdom is a brief battle. But that mode of engagement is arguably not good, because in a debate, the rules of engagement are that you assume that there is one right answer, it's combative, it's about winning, it's about listening for flaws in the other's arguments, defending your assumptions, pursuing your outcome, and there are asymmetries of engagement. If I engage with a politician, I as an academic, because I worry about the regard of my academic peers, stick to certain rules of impartiality, honesty, representing uncertainty, whereas my opponent may not abide by those rules. And of course, it's entertainment. Seeing whether Ed knocks one off whoever is something that is fun to watch, and you don't even have to listen to what they're saying. So this forces people further apart. Dialogue, on the other hand, assumes that you have everybody has something to offer. It's collaborative, finding common ground, listening to understand, exploring assumptions, discovering new possibilities, and seeking constructive progress. So public dialogue and dialectic is the way to bring people together to address these issues. Not that Roger will admit that the media find debate very helpful because they just have two people, not many, and it's very entertaining. Finally, scientists often forget that we deal in particular language and facts. We do that, we're trained to do that with other scientists, to efficiently transfer and convey complex ideas that we've been working on and are highly nuanced. But this is a very recent way of humans to talk to each other, and that storytelling, the power of narrative, is the way that the majority of people make up their minds about what they believe in. So just very quickly, one success story which is about adaptive planning. In the case of the London Climate Change Partnership and the Environment Agency, the Thames Estuary 2100 plan, I would claim, is an example of where the dialectic, where the dialogue has been good. Experts have got together with the science community in their proper role. It's been accepted that there are irreducible uncertainties in what the future sea level, let's say, will be around London, and that's been taken into account in a decision pathways approach where the future has been mapped out in an adaptable way. And then, so for my final comment, we've heard a lot this morning about energizing and mobilizing innovators. And so I'll just end up with an insight from Thomas Edison, who, of course, didn't invent the light bulb, but certainly made a lot of money out of bringing it to market. And he said the following. He said, opportunity is missed by most people because it's dressed in overalls and looks like work. And it's through our communication that we have to get people over that hurdle. So thank you for your indulgence.